hand is directed towards the microphone or something like that.
Okay, now?
Yes, sir. Now much better.
Oh, you're telling me to sit without the fan. Okay, fine. Okay, we can start. Okay. So, students. So, the most here this neural networks, whatever we are going to study. Okay, it's the part of the deep learning. Okay, so but we are not going to uncover the subject of deep learning, but we will try to learn some very important concepts with respect to neural networks. Okay, so mostly it is used in deep learning. Okay, the most fundamental unit of a deep neural network is called as an artificial neuron. Okay, now why it is called as a neuron? Where does this inspiration comes from? Okay, this particular inspiration comes from the biological term, more specifically with respect to brains. Okay, so how our human brain works, how our human brain receives multiple inputs, processes the information, and tells our body to react. Okay, tells our body to react. Okay, the same concept we would like people are wanting to implement in computers. Okay, so say for example, given a particular person called as a John. Okay, John might on his way, say for example, if he's traveling in a bus, he might be eating. He might be at the same time he's seeing some particular movie. Suddenly he will pop up through the window. Okay, he will see some mother carrying a child and going. Suddenly, in the next instance, something funny might be happening there. He will suddenly laugh. Then suddenly the conductor will come and he will tell him to get the ticket. Immediately he will respond. So in a given instance, so many inputs, okay, John is receiving while traveling in a bus. And based on the inputs, what is happening is so many neurons of his brain cells gets fired up. Okay, if the conductor comes and asks, he decide whether to get the ticket or not get the ticket. So based on some certain conditions. Okay, when a particular person is fighting, he wants to stop the bus, get down and stop the fight or not. Some particular neurons fire. Okay, he's eating parallelly, some neurons fire, and it is telling the human body, okay, two neurons are getting fired. It goes back to the spinal cord. His actions of the bones are coming into picture. He takes the food in his hand and he puts them in the mouth. Okay, so can you see the particular neurons are getting fired and physical action is taking place. Okay, on multiple instances in a given particular time, and so many inputs have been received. Okay, then certain things he neglect. So for example, he's just sleeping on the way. Okay, suddenly some sound comes. He just opens his eyes, closes his eyes, and he continues to sleep. That time what happens, his neuron doesn't get fired up, right? Okay, he just opens his eyes, closes his eyes, he does not react to anything, he continues his sleep. Okay, there are few students might be, whatever if I teach, they might sleep. Okay, not you people in other sections. Okay, they might sleep. Okay, and irrespective of whatever happens, the neuron don't get fired up. Okay, so but when you want your neurons to get fired up, okay, you start thinking about it and physical actions comes into picture. Okay, so biological neurons, the same concept, students, we want it to be implemented in the computer, where the computer also takes so many inputs, processes the information and produces the output. So first we look at, okay, a slight simple biological neuron, how it looks like in a computer, in a human brain. Okay, this is one particular neuron. This is another neuron. Okay, now this particular cells, can you see over here, okay, is the receive signals from the other neurons. It's just called as dendrite. Okay, can you see, these are the ones which receives signals, input is given over here. So dendrite means what, students? Input is given over here to the neurons. point of connection to the other neurons is called as synapse. Can you see the point of connection? Point of connection is called as synapse. Okay. So soma, can you see this one? The main one. They process the information. Okay, it processes the information. So it receives the information. This is the interconnection with the other neurons, and this is the one which processes the information, which is called a soma. Okay, and axon, can you see? Axon transmits the output. So it does the processing, right? Okay, from here it transmits the output to the other neurons. To the other neurons. So there are 4 things you have to just get into picture. Okay, I'm just telling you, we are not going to, why we are teaching you is when we are the same concept is applied, right, with when I'm going to teach you the concept of perceptron, all those things, and MP neurons in the upcoming slides. Okay, so dendrite, it receives the signals. Okay, soma is the one which processes the information. Okay, synapse is the one what it does. Synapse is the one what it does. It is the interconnection among the multiple neurons, and axon is the one which transmits the output. So here will be another neuron. Okay, here there will be another synapse, and from here it is coming, and here it is a part of the interconnected network. Here this is another soma, and here there will be another input. So and the process continues. Okay, so basically receives the information, processes the information, and transmits the information, and it is interconnected. It is interconnected to the other networks. Okay, other neurons. Okay, so say for example, now what happens is you see, okay, and you hear. Then you decide, then your neuron shoots up. Okay, then your neuron shoots up. Then you decide whether you want to laugh or you don't want to laugh. Okay, so now, of course, it is just not a single neuron which does all these things. Okay, it is basically, neurons are basically a hierarchical layer. Okay, so one neuron will transmit the information to another neuron, from another neuron it goes till here. Okay, it goes till here, another neuron, because it's a group of massive interconnected networks. Okay, it goes here, it goes here, it goes here, it goes here. Finally, you trigger an information whether you want to laugh or whether you don't want to laugh, based on some certain conditions. Okay, massive parallel interconnected network of neurons. So the sense organ relay the information to the lowest layer. Okay, so sense organ, right? Eyes, ears, nose, from the lowest layer, and it gets transmitted to the upward layers. Okay, neurons that they are interconnected, and these neurons may also fire. Can you see? There are neurons. Can you see this red color? Okay, they are transmitting the information from the one neuron to another neuron, and not all neurons are coming into picture. Okay, see here, when I'm telling you to, if I'm talking you about your, can you please remember your physics teacher name of your 12th standard? Now, definitely many people could have remembered. So how does that particular teacher name is coming into your mind? So that neuron has stored the information. Okay, this is a neuron. Okay, and my physics teacher looks like this. Okay, he or she was good to me. Okay, she used to help me, so and so and so. And you will remember about all good things about her. Okay, chemistry teacher, another neuron gets shoot up. English teacher, another neuron gets shoot up. Maths teacher, your brother, your sister, your parents. So there are so many neurons. Okay, if the same thing when you are trying to recall also, neuron gets shooted up. So, and it is used to process the information also, retrieve the information also, store the information also. Okay, so usually students, an average human brain has how many? 100 million neurons. Just imagine. 100 million neurons, an average, okay, an average human brain have more than 100 billion neurons. Okay, so it is massively connected. Okay, so that's what I have told you. Now you will not laugh for everything, right? Okay, you will laugh only when some visual, somebody will laugh only when the visual is funny, somebody will laugh when the speech is funny, some neuron will trigger when the when the text is funny. Some neuron will fire when visual and speech is funny. Somebody will laugh when visual, speech, and text and everything put together is funny. So it is being arranged in a particular hierarchy in a different varieties of ways. Okay, so now let's look at how the neurons in the brains are arranged in an hierarchy. Okay, so when a human eye receives and senses whatever it is, okay, when he hears or when he sees whatever it is, okay, we illustrate with the help of visual cortex of a part of the brain. And you see which is V1, V2, V4. Okay, there are some important parts of the brain, okay, where human transmits that information to. Okay, starting from the retina of the information to the relative severally layers, as I told you over here. Okay, when a human sees, it starts from the lower and it goes up. Can you see? And it goes up in a hierarchy. And then you what is our objective? Okay, whether you laugh or whether you don't laugh. Okay, whether you do an action, whether you eat or whether you don't eat. Seeing a food, immediately instant, so many things happens, right? Just imagine if a person is brain dead. What happens? No neurons get fired, no action is happening, no blinking of an eye is happening, nothing is happening. That is why we call this as a brain dead. Brain does not function. Why do we tell that word? Because neurons don't get fired. It does not do anything. Clinically dead. Heart stops. Heart stops means neuron stops to trigger. So now what happens here? Okay, so if you see here, V1 and V2 and A1T is a hierarchy. Okay, it's a hierarchy. Can you see? It goes here. Okay, V1, V2, something is a hierarchy. Can you see? A hierarchy. It is coming here, V1, V2, and it is coming here. Let me just. Can you see? It's a hierarchy. Can you see? It's a hierarchy. It goes till V1, V2, V4, and it is coming here. Now what happens over here? So in the first layer, students, what it is telling is, it first detects the edges and the corners. What is happening? Okay, in the second layer, it forms the features of a nose, mouth, eyes. Okay, and in the third layer, it detects the high level faces and objects. Okay, like face. Okay, and then it decides to take to a condition that whether I should shake my hand, whether I should move my body, and then it goes around and round and round. Okay, this is a very simple biological terminology. That is all, students. This has nothing to do. This is just for you to explain. Is it clear till now what is happening? Is it clear till now what is happening? Hello? Is it clear till now, everybody? Raise your
Yes,
hand.
sir. Yes, sir.
Yes. So when I'm telling you to raise your hands, kindly please quickly raise off your hands so that from 14 it should jump to 54. Okay, so that I can come back quickly and start again the process. Okay, fair enough. Good, very good. Okay, so we will move on. Okay, so now students, now we will move on to a concept called as Mikolaj-Pitts neuron, which is otherwise called as MP neurons. MP neurons. Okay, Mikolaj-Pitts neurons. So, which is otherwise called as an MP neurons. Okay, so now what does it do? Mikolaj, neuroscientist, and Pitts, logician, proposed a highly simplified computation model of the neuron. So what did they do? So okay, they have the inputs x1, x2, x3, x4, x5, xn, and then okay, they aggregated this input. What input? A binary input. Okay, 0 and 1, or you can call it as a Boolean function. Okay, and then based on this aggregation, can you see x1, x2, x3, xn, xn? Okay, which is either 0 or 1. Okay, it's a Boolean binary. Either the input will be either 0 or 1. After aggregation, the function f decide whether I have to laugh or not laugh. That is whether I have to fire or not fire, whether I have to trigger or not trigger. Everything is same, right? So based on this aggregation function, okay, it will trigger. Okay, whether I have to fire or not fire. Okay, that is, if it is zero means, if the aggregated function, if it is zero means, I will not do anything. I will continue to sleep. Just to make you understand. Okay, that is zero. Okay, if it is one means, okay, I will do some action. I will do some action, fire. Fire. Okay, that is, now students, okay, one more thing. I will first let me explain you. Okay. Okay, now the input, okay, this input, what I am telling you, x1, x2, x3, x4, okay, is of two types. Input is of two types: excitatory input or inhibitory input. Okay, now say for example, students, I want to trigger. Say for example, if you want to watch a movie, say for example, my favorite actor is, say for example, say some actor A. Okay, and I should have the music according to my taste. Okay, my mood. Okay, and my director should be my some L. Okay, some Lincoln. My favorite director should be Lincoln. Okay, then my music should be a fast my music. Okay, and my favorite actor should be some, say for example, Arnold. Okay, and then it should be a thriller also. Only then, only then I will trigger. Okay, I like the movie. I will fire. Okay, I will watch the movie. Okay, watch the movie. But when I am talking about inhibitory inputs, input may be whatever it might be. Let it be my favorite actor. Okay, my favorite music. Okay, my movie is released. Okay, he's my favorite actor. My favorite music is there. My favorite director is there. And my thriller is also there. Okay, but if this inhibitory input is on, that is, I am not well. I am not well. I am sick. Okay, I am injured. I am injured. Okay, or something has happened. My mood is totally off. I am least interested. Irrespective of whatever may be the input, if this input is on, the output is always zero. That is, the triggering is always zero. I am not going to fire my neuron. Are you getting the point, students? What is inhibitory input? Yes? Are you getting the point, students?
Yes, sir.
Hello? So, if my input is inhibitory, irrespective of whatever may be the other inputs, okay, I am done. Okay, because I am sick. Okay, whether the movie have come out, okay, let it be my favorite actor, my favorite music, okay, my all the parameters, what I want, okay, is satisfying. But today I am not well. I am not going to fire my neuron. Okay, that is called as an inhibitory inputs. Okay, having said that, what is the other one? Excitatory inputs. Okay, what is excitatory input means? Now when I add up the summation, okay, when I add up all the aggregate functions, when my input g of x, okay, can you see? G of x. So when I add up is greater than some threshold, okay, then I will fire. After adding up. Okay, say for example, okay, I am a very, very, very serious movie watcher. Okay, that is, my favorite actor should also be satisfied. My favorite musician should also be there in the picture. My favorite director should also be there, and it should be thriller also. Okay, yes, all my, say for example, threshold, and the movies come up. Okay, so my threshold is 4 over here, just to make you understand. So is this movie satisfying all the 4 parameters? Yes. So 4 greater than or equal to 4. Yes, it is satisfying. Then I will trigger, yes, I will watch the movie. I will like the movie. Okay, another story guy is there. Irrespective of whatever is there, thriller is there, I will watch. Then his threshold will be 1. His threshold will be 1. When I aggregate, if it is 1, okay, it is 1. Okay, and if it is greater than, okay, whatever may be the inputs you are providing, if I aggregate, if it is greater than or equal to 1, so that threshold is the theta over here. Okay, if it is 1, then what? It is able to fire. But no, okay, I am a thriller watcher, but the movie which is coming up, okay, at least, okay, I am a thriller watcher. What is the chance which I will watch or not? Here again, it is coming to this here. Everything, whatever we are studying in the supervised learning, have that in the back of the mind. We are going to classify whether I'm going to watch or no, whether the Raj will play tennis or no, how we did in the decision tree. Okay, the same thing is happening over here also. Okay, so now whether I'm going to, my threshold is 1. I am a thriller watcher. But the movie which is coming up, it is neither my favorite actor, favorite musician, favorite thing, and neither of the thriller. Will I watch? Will I trigger or no? When I add up the sum, will I add up the sum whether with a trigger or no? The movie which has come up in the latest one. Yes or no, students? Will it trigger or no? Will it fire or not?
It won't fire.
It won't fire because none of the parameters are not matching. So if it not fire means if it is less than 0, it will not fire. If it is greater than threshold, it will fire. If it is less than 0, it will not fire. That's all, students. Okay. So this theta is the thresholding parameter. Theta is called as a thresholding parameter. So after aggregating, I will check with my theta. Okay, I will check with my theta. If it is greater or equal to, it will fire. If it is less than or equal to, it will not fire. Okay. So now let us implement some Boolean functions according to MP neurons. Now listen please. In MP neurons, the input is also binary, that is Boolean, and the output is also binary, which is Boolean. Okay. So, students, if I have 3 inputs, okay, if I have 3 inputs, okay, the sum of the inputs, okay, if it is greater than the threshold, it will fire, else it will not fire. Okay, say for example, if I am setting my input as 3, threshold as 3, so my favorite actor should also be there, my favorite director should also be there, and my favorite musician should also be there. Will it fire or no? If a movie, latest movie is coming up, will I watch this movie or no? Hello?
Yes, sir. It will fire if
Fire.
if it is greater than
If
threshold.
yes, no, see here, all 3 parameters. Okay, my favorite actor is also there, my director is also there, and my favorite music is also there. It will fire. Okay, now say for example, if I'm keeping the threshold 3, but a movie is come up, but my favorite actor is there, my favorite director is there, but my favorite musician is not there. Will it fire or no? Will I go watch this movie or no? Will I go watch this movie or no?
It won't fire.
Yes, students, it won't fire. Why? Because it is less than the threshold. It is less than the threshold. Okay. For AND function, okay, when will the AND function fire? So if I have all the inputs as 1, 1, 1, okay, so 3. In this case, if I'm setting the value as 3 as a threshold, okay, but what about the OR function? So if I have 1, 0, 0, also the minimum value I can keep, okay, threshold to have 1, okay, can you see, I am making it as to fire, okay. So now, if you look at this one, okay, NAND, can you see, what did I tell you, students? What did I tell you? The circle represent an inhibitory input. If this inhibitory input is 1, okay, if this inhibitory input is 1, okay, what will be the output? If for example, you have 0, 0, x1, x2, right? x1, x2. Okay, 0, 0, 0, 1, 1, 0, and 1, 1. So these two inputs, so definitely x2, okay, if it is 1, right? You see? For these two inputs, definitely it is not going to fire. Yes or no, students? You are able to understand? Hello? Okay, why? Because it is an inhibitory input. The dot circle represents an inhibitory. What did I tell you? Inhibitory means what? Okay,
In
what did
any
I tell
case,
you?
it won't fire.
Okay, if that particular input, okay, if this particular input is on, that is, I am sick, irrespective of whatever may be the other input. Okay, whatever may be the input, I'm sick, I'm not going to watch that movie. Okay, it won't fire. Okay, so the other two left is 0, 0, 0, 1, 1, 0, and 1, 1. So this is gone out of the box. This is gone out of the box. For these two inputs, it will not fire. So this is also not left. So maximum is this one I can have. 1. Okay. So the next one. OR function. So can you see both of them? 0, 0, 0, 1, 1, 0, 1, 1. Can you tell me what will be the value over here? Can you tell me what will be the value over here? So both are inhibitory inputs. What will be the value over here? Come on, students. Yes, please.
X2
What
is
will be the
the
threshold over here? Yes, pa?
X2 is the inhibitory value.
No, see here, both are inhibitory now. Both are inhibitory. X1 is also inhibitory, X2 is also inhibitory. Can you see? The small circle represents the inhibitory value. Now, what will be the value of this threshold here? If I want to set theta.
Sir, it won't fire now, sir. It is secure.
Exactly. So, what will be the value? What can be the maximum value of this threshold?
Sir, if you put 0, 0, then it will be inverted
That's
to
all.
1, 1.
No, see here, we are talking about here, if I put 1 over here. Okay, so 1 means what is the inhibitory value? The output will be 0. Okay, can you see? So the maximum value, okay, the threshold, okay, I'm talking about the threshold, okay, it will be 0 only. Okay, the not function, we definitely know that our maximum value is 0 only. Okay, so now having said that, students, can any Boolean function be represented by MP neurons? Before answering this question, let us see some geometrical terms. Okay, now students, now we will see about OR function. Okay, we will see about OR functions with respect to the MP neuron algorithm. So what is the MP neuron algorithm states? What is the MP neuron algorithm states, students? Okay, MP neuron algorithm states okay, so you aggregate, okay, you have the inputs x1, x2, xn, you aggregate this input, okay, you aggregate this input when if it is g of x is greater than theta, g of x is greater than theta, then it will fire. If g of x is less than theta, it will not fire. Okay, very simple one. Okay, so now let's talk about OR function. Okay, let's talk about OR function. So now what is OR function? 0, 0, 0, 1, 1, 0, and 1, 1. So what will be the g of x of this? G of x of this. So 0 means 0. Okay, you are adding. Okay, 0. Okay, this is 1 when you add 0 plus 1. So g of x. Okay, I'm summing up, right? I'm summing up two inputs. This is x1. This is x2. Okay, so when I aggregate this, 0 plus 1 is 1. So 1 plus 0 is 1. And 1 plus 1 is 2. Okay, so what is the theta given over here? What is the theta given over here? 1. Okay, so if g of x is greater than theta, if g of x is greater than theta, so
Sir, in the
theta is what?
last
1.
one, won't it be 1 because it's like an OR function?
No. See here, I am adding up. I'm just doing the g of x.
Okay, so the arithmetic addition.
arithmetic calculation. Okay, so g of x, I'm just using the formula. Okay, MP neuron algorithm. So g of x. Okay, so 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 2. Okay, now see. Okay, so now you tell me. So why? So if g of x should be greater than theta, g of x should be greater than or equal to theta, it will fire. Okay, if it is a g of x is less than theta, it will not fire. Okay, so g of x value is what? In this case, 0. 0 greater than or equal to 1. True or false? So which one is done? So if this is condition means it will fire 1, 0. So 0 less than or equal to 1. Yes or no? So it will fire 0. Done. Okay, so then 1. So is 1 greater than or equal to 1? Is 1 greater than or equal to 1? G of x greater than or equal to theta is 1, right? Threshold is 1, right? Yes or no, students? Hello?
Yes, sir.
So 1. So what it will fire? 1. Okay? So then 1. So again, g of x. 1 greater than or equal to 1. So it will fire 1. Okay? Then 2 greater than or equal to 1. Can you see? Fire 1. Is it clear, students? Is this clear now? Is it clear? Is it clear?
Sir. Yes, sir.
Okay. Now students. So having said that, okay, now what is happening? What I am trying to tell you here is through the OR function of MP neuron through Boolean gates, that is OR function of MP neuron through Boolean gates. See x1 plus x2. Okay, so when I'm adding x1 plus x2, okay, and when it is greater than or when I'm summing up, when it is greater than or equal to 1, it fires. Okay, and if it is not, it doesn't fires. So I can draw 2 points, right? x1 and x2. So what are the 4 points I can draw? 0, 0, 0, 1, 1, 0, 1, 1. Yes or no, students? Yes or no?
Yes, sir.
Hello? Yes. So what is the value we have got? 0, 0, 0, 1, 1, 0 and 1, 1. So what is the value we have got? 0, 1, 1 and 1. Okay. Now, what is the equation? x1 plus x2 equal to 1. Okay. x1 plus x2. Can you see? The equation is x plus x2 equal to theta, which is equals to 1. Theta is 1, right? So if I draw a straight line, can you see, students? So 0, 0, 0, 1. 1, 0, 1, 1. So if I draw a straight line, 1, 1, 1. So when I'm drawing a straight line, for anything, okay, on this side of the line, it is all zeros. It is classifying it as zeros. Anything above this or on the line, it is classifying it as 1. It is able to classify it as 1. Can you see? All the zeros point, it is classifying it as 0. Anything on the line or above the line, it is able to classify it as 1. Can you see? 0, 1, it is classifying it as 1. Okay? And 1, 0, it is classifying it as 1. 1, 1, it is classifying it as 1. Anything above this line, it is classifying it as 1. Getting the point, students? What is happening here? Linearly separable using an OR function. Okay? Hello? You're able to understand what is happening here?
Yes, sir.
Okay, I will just tell you another example. Okay, with the help of an AND gate. Okay, now watch, students. Now, okay, so that is what I have written here. Anything below this line, it is classifying it as 0. Anything above this, it is classifying it as 1. Now let's see an AND gate. So 0, 0, 0, 1, 1, 0 and 1, 1. Now g of x. I am applying the MP neuron algorithm. So 0 plus 0 is 0. 0 plus 1 is 1. Okay, and 1 plus 0 is 1. And 1 plus 1 is 2. 1 plus 1 is 2. Now what is the threshold I have kept here, students? 2. Okay, that is theta. This 2 I have kept here. Okay. Now what is the algorithm, students? So g of x should be greater than or equal to theta. If it is yes, it will fire, which is 1. If g of x is less than theta, it will fire 0. It will fire 0. Now see, apply 0 less than or equal to 0 less than or equal to 2. Theta is 2, right? 0 less than or equal to 2. Yes, so 0. 0. Is 1 less than or equal to 2? So it will fire 0. Okay, students, getting the point? Again, 1 less than or equal to 2? Yes. So again it will fire 0. Okay, then 2 greater than or equal to 2? 2 greater than or equal to 2? What it will fire? What it will fire, students?
So 1.
1. Can you see? So this is the thing. So now how can I draw this line over here? Like how just I draw this one line, right? Okay. Line, right? That is anything with it. But here, what have I got? Can I draw a line here? Where I can draw? I can draw a line only have 1, 1. So I can draw a line 1, 1, something like this. Okay, so which can meet 2, 0, 0, 2. It will meet somewhere over here 2, 0 and 2, 0 over here. That's all. Now, anything below this, it is classifying it as 0. Anything above this or on the point will classify it as 1. Can you see, if you see this one? Can you see? I've drawn the line. Now, if you see this, what is the one which you have got? So 0, 0, it comes as 0. Can you see? Let me draw this one. Okay, so I'll just write it down over here. 0, 0, 0, 1, 1, 0 and 1, 1. What did we get? 0, 0, 0, 1. This is what we got, right? The final y. Okay, and when we draw the line, so only with 1, 1, we are able to pass the line. So now if you see 0, 0, it is classifying it as 0. And here it is falling below the plane, linearly separable with. So 0, 1, 0, 1, again it is lying below this line. Again it is classifying correct. 1, 0, it is lying below the line. Again it is able to classify. Correct, 0. But 1, 1 on the line and anything above the line, it is able to classify it correctly. Linearly separatable. Are you getting the point what I am trying to say over here, students? Hello? Hello?
Yes, sir.
Yes, sir.
Okay. Okay. The last one is I will talk about tautology. Okay. So tautology, if you see, what is the equation? 0, 0, 0, 1, okay, 1, 0 and 1, 1. If I write g of x, the algorithm, MP neuron algorithm, so it is 0, 1, 1 and 2. Okay. Now, theta is set as 0. Okay, theta is set as what? 0. So 0, so g of x, okay, if it is greater than or equal to theta. So 0 greater than or equal to theta, greater than or equal to theta, theta is set as 0. 0 greater than or equal to theta. Hello? Students, please help me out. 0 greater than or equal to theta. The theta value is 0. So what will be the value of phi? What will be the value of phi, students?
1.
1. Very good. Is 1 greater than or equal to theta? Is 1 greater than
Yes,
or
sir.
equal to theta? So what will be the value
Yes.
of phi? What will be the value of phi? 1.
1.
So 1. So 2 greater than or equal to theta?
Yes,
Yes? Yes. So what will be the value of phi? What will be the value of
1.
phi? 1. Okay. So what did we get? 0, 0, 0, 1. You know the tautology truth table also. 1, 0 and 1, 1. Okay. So 1, 1, 1, 1. Where is the maximum, minimum point where we can pass the line? You see, I can draw a line something like this. 0, 0 is the minimum point because it is 1. Right? Now anything above this line it is classifying positively. Anything below this line, it is classifying it as 0. See, 0, 0, yes, on the line and above the line, it is classifying it as 1. 0, 1, see, again, it is classifying it as 1, category 1. 1, 0, it is classifying it as category 1. 1, 1, it is classifying as category 1. As category 1. Okay? Can you see x plus x2 theta, which is 0, which is classifying, and it is able to classify it correctly, linearly separable. Okay, this is the last one, and with this I will end up over here. Okay, what if we have more than 2 inputs? That is 0, 0, 0, 0, 0, 1. Okay, 1, then 2, right? Then 3, then 4, then 5, then 6, then 7. So if I do g of x, it is 0, 1, 1, 2, 1, 2, 2, and 3. So what is the threshold I have kept it as? What is the threshold? Okay, we have kept it as 1. Say for example, if I have kept in the theta as 1, then everything what it will shoot, students. So except this, it will shoot 0. Everything will be, the value of y will be 1. So if the value of y is 1, and if it is a 3 input, what will I go? This is a line, right? What will I go for, students? Can anybody tell me what will I go? For which type of methodology will I go? Which type of methodology will I go? If it's 3 dimension. 2D, you go
So will
for
it
like,
be a plane equation?
very good, excellent. Okay. So now anything you need to come up with the line so that everything we have, okay, will fall within this line. So that everything, this alone is 0 and the other ones as 1s. Other thing one as 1s. So if you see here, okay, so all the points will lie above all these things, okay, will lie above 1. And can you see the other side of it? You are not able to see because it's just on the other side of it. Okay, that 0, 0, 0 is on the other side of it in a plane. Okay, but if it's more than 3 dimensions, what you will go? Where you will go, students? If it's more than 3 dimensions, what type of methodology will go? What type of methodology will go? You'll go for
Planes,
hyperplanes.
sir.
Yes, hyperplanes. Very good. Hyperplanes. Okay, students. So this is all about, okay, the problem, okay, student, the problem with MP neuron is it is a fixed slope. Okay, it is a fixed slope. Okay, fixed slope. Brute force, because you need to change the value of theta every time. Okay, equal importance is given for all the inputs. Okay, unable to handle non-Boolean. Apart from 0 and 1, it cannot handle any numeric integer. Okay, and it is non-linearly separable for XOR. For XOR, like how we have done for OR and tautology and other Boolean functions. Okay, for XOR, it is non-linearly separable. You cannot classify. Okay, so in general, so linearly separable for Boolean function, there exists a line plane which produces a line something like this. For AND, for OR we saw like this, AND we saw like this, for tautology we saw like this. So anything above it, okay, which produces one line of it, it is able to classify it as 1, and below this, it was able to classify it as 0. This is for OR, right? For AND, anything above this, it was able to classify as 1, 0. So above this, it was able to classify it 1, 0. This, it classify as 0. So linearly separable for Boolean functions. There exists a line plane such that all inputs which produces a 1 lie on one side of the plane, and all inputs which produces the 0 lie on the other side of the plane. And we are able to linearly classifiable. Is it clear with MP neurons till now? Everybody?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So I hope J component, you people have thing. When was the last date I have told you for the J component submission? J component first review.
Sir, you haven't informed us any
No,
date.
no, I have told you. I have told you. Okay, I have told you. But okay, no, never mind. Okay, so this 1 second. Okay, so you are expected. What is expected from you is